Hello everyone. We have a question. It says that the equation of a curve y is equals to 4x square minus kx plus half k square, and the equation of the line y is equals to x minus a. Basically, we have equation of line and equation of curve where k and a are constant, given that a is equals to minus 7 upon 2. That means instead of a, we could place minus 7 upon 2. That means we have done over here, instead of x minus a, instead of a, we have written minus 7 upon 2. The condition says that find the values of k for which the line is a tangent to the curve. Tangent means point of intersection, means common point. And when we say common point, definitely make the equation of the curve equal to the equation of the line, because we have a common point. So here you can see that we have written the equation of the curve equal to the equation of the line, and instead of a we have written minus 7 upon 2, and this negative times negative would become positive, and there we are. Now simply rearrange this equation into a proper quadratic form. First, as we can see, we have x square. We do not have any other x square, so 4x square is there. We have kx over here. We have this x over here. When moved over here would be minus x. Take x as common, negative outside, in the bracket k plus 1, and half k square. K is a constant, and 7 upon 2 over here, minus 7 upon 2. So this complete is a constant according to the quadratic equation form. Condition was it is a tangent to the curve. That means point of intersection is 1. That means the discriminant is equal to 0. So use the condition of discriminant equal to 0, b square minus 4ac is equals to 0. Place the value of b, a and c in the given, and instead of a write 4, which is the value of a. Instead of b write negative and k plus 1, which I have written over here along with square. And instead of c, I have written half k square minus 7 upon 2, because both contain the denominator 2. So I have written k square minus 7 divided by 2, as you can see over here, because both contain the denominator. So I have converted them into a single fraction. Now, as you can see, I have cancelled this 2 with this 4 so that we could go for a simplification. First of all, this negative square would become positive. Apply the formula of a plus b whole square, which would be a square plus 2ab plus b square. Then minus 4 times 2 is 8, and multiply that by k square and minus 7, and would result in this condition. Rearrange the condition, add up the like terms, the k square and whatever the like terms are, and finally rearrange them in this manner. As you can see, after rearranging it, I got minus 7k square plus 2k plus 57 equal to 0. I can use this also as an equation and get my values. But no matter, if you take minus 1 as common and then divide that minus 1 on the other side, and definitely 0 divided by minus 1 would be again 0. That means if I take negative 1 as common, this negative 7k square would become positive, this positive 2k would become negative 2k, and this positive 57 would become negative 657. It is not wrong that if you use this equation, you can use any of the equation and get your required result. So finally, we have this particular quadratic equation according to the question. Find the values of k. So definitely we have a proper quadratic equation equal to 0. We can use the quadratic formula, place the values of a, b, c over here. The value of a is 7, b is minus 2, c is negative 57. Place it over here. Just simplify it and get the two values of k. As you can see, we have 3 and minus 19 upon 7, which was actually the requirement of the question, where it said that find the values of k, and we are done.